Advancements in any industry are fundamentally tied to innovation in materials science. In other words, if there is no advanced materials, there is no advanced technologies. Material science and engineering is incredibly broad and interdisciplinary, spanning nanoscale synthesis, microscale assembly, and macroscale manufacturing. So to effectively work in this space, and really depending on the scale of focus, we need expertise in chemistry, rheology, and processing. And here at Multi-Scale Materials Design Lab, we work across all these skills to develop precisely engineered materials to address environmental challenges, such as removing invisible electromagnetic waves, ensuring clean water access, and also capturing carbon dioxide from our atmosphere. Our students are engaged in highly interdisciplinary chemical engineering projects. They synthesize functional nanomaterials and polymers, they assemble them into soft materials, and then they shape them into final products such as aerogels by additive manufacturing and 3D printing techniques. So far, we have created many different functional materials such as magnetic or electrically conductive materials, and we are really excited to see their use in different industries such as aerospace, automotive, and other advanced fields and industries. The University of Waterloo in the Department of Chemical Engineering has provided us with exceptional infrastructure and support so that our graduate students can thrive and push the boundaries of material science and engineering toward a cleaner and greener future for both our generations and the ones to come.